Yes, I left off the last episode showing how at least you got here on Earth. I neglected to point out to the strong force. Now, if you've had days, for instance, that nothing seems to work, everything is going wrong, can't seem to hold everything together, you feel like you're flying apart at the seams. Well, if you look at your atoms are made up of positive protons. So why don't you? The atoms fly apart then, because like charges repel. What's holding them together? And what's holding you together? Must be some strong force stronger than the electromagnetic force. And that's what we call the strong force. And that keeps you from flying apart. So let that force be with you. Now, where we left off before was the creation of the moon and how the moon is important. But then life itself on Earth for the next billion years, we said that the Earth in the solar system was 4.6 billion years old. So in the first billion years, it was still so chaotic and hot that life would not be able to exist. So it would be around a billion years or so before it was conducive for that. How did that happen? Again, science has some speculation. They can say, well, they need this, put this ingredient with that, mix it up, you know. But it's only a speculation. It's not. It hasn't been. It's not a definitive theory. In other words, it's not a law. Because they've tried to create life in a lab and have not succeeded. So, if you know how it's going to happen, why can't you then take it back to the lab, put it together, and get some life? Get some chemicals. Get some life out of the chemicals. Well, there was one person that he's not really acknowledged by the scientific community. It sort of gives them a bad name, and the science itself a bad name. But to be truthful, he didn't create life. He only took a life that had died from existing people, sewed them together, added a speck of lightning, and made it come to life. As I say, they don't like to talk about that because it gives science name. They think of mad scientists like the witches in Macbeth, going down into a dungeon or in a cave and brewing up some magic potions. Well, the guy's Frankenstein was his name. The scientist was Frankenstein, and the experiment didn't turn out that well. It created a monster, went around terrifying people. And for those of you that aren't from this planet, you'll know that I'm using an example of a sci-fi movie or sci-fi fiction, because no one has created life. And for the first few billion years, life was very, 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 very dull. You just change yourself from one cell to two by splitting up, cloning yourself. When did you first have sex? Well, the type of sex that we think of as sexual intercourse and so on is half a billion years ago also. And then things got interesting then. All sorts of plants and animals sprung up, different species. Now you, of course, with sex, you have the male and the female coming together to form the offspring. You get, for instance, half of your genes, or cells, if you like, and half of from your biological father and half from your biological mother. So you are really part of your mother and dad. When someone comments, well, it's just like your mother or just like your dad, well, physically speaking, your DNA, your cells, are really half of each. And you get bigger and grow. I should say first, the core of your cells is, at the core is deoxyribonucleic acid, DNA. And that is where you get most of your physical characteristics or traits. The color of your hair, the color of your eyes, the size of your nose, etc., etc. And your DNA is like a ladder with rungs in it, and it's composed of 4 different chemicals, which I won't bother naming. And when you grow, it splits apart down the middle, and then there's if it's the left and right side duplicate themselves. The left side matches up with the right side exactly, billions and billions of times. Sometimes there's a part of the DNA is changed, doesn't match up quite. Could be radiation, cosmic rays, or whatever. And then if it could then, because your DNA is changed, it could then have different physical traits or characteristics. So, and life itself you had a few close calls. If you look at the geological ages, there's like between the different ages, the Triassic and Jurassic, the Permian, Cambrian, etc. There's often associated with major upheavals or almost catastrophes. 5 major ones that we know of, and others, but one in particular, happened 225 million years ago. Like before that, when life first started from the oceans, came up onto the land and created the plants. So you have the animals and the plants. They are symbiotic, if you like. The plants, a process called photosynthesis, take the light of the sun and convert and taking in carbon dioxide and then giving off oxygen. Animals breathe in oxygen, and through the process of splitting up the DNA, and then give off carbon dioxide. And plants as well, when they die, they fall down, they rot, and they give back then carbon dioxide. But before 225 million years ago, one smart-ass plant, he said, I'm going to get more of that good sunlight, so I'm going to grow higher. And became a tree. But when he tried to rot, there was nothing there to help him rot. There were no termites, for instance. And for millions of years, it just fell down and was squashed into coal. And at 225 years ago, in I think it was was it Ukraine? Or was it over in Russia? The or in yeah, part of Russia. Had so much volcanic activity, it heated everything up, and many of the scientists think it ignited the coal, and with that, and all the bombardment and all the lava, volcanic activity, and the fire, it exterminated, if you want, 70% of all living life, 70% of all species, 90% in the ocean, and the rest on Earth. So you had a close call there. You made it through that. Now during it, and then the dinosaurs came about, right? They were here for 160 million years. During that time, the continents on Earth started to split apart. At one time, they were all at one continent called Pangaea, and then they started splitting apart to more or less the position they are now. Still moving, but we can't see it; it's so slow. And how do we do that then? Well, if you look at it, you can almost see yourself that they kind of sort of fit together like pieces of a puzzle. South America, and South Africa sort of come together. So maybe they were together at one time, but that's really only a hypothesis. You need to have evidence to support that hypothesis. And the guy that did that was called Wagner. And so he took, from this side of the Atlantic, took some fossils, plants and animals, and compared them with fossils on the other side of the Atlantic, and found them to be the same species. And nowhere else, on any place else, on any of the other continents. So they must have then been in the same area when they lived. He did the same with land formations. Found that something started on the Atlantic, this side of the Atlantic, and continued on the other side. And the sedimentary rock, which has different layers, depending on how it was laid down, was the same. Could match up from the left, from the one side of the Atlantic to the other, indicating that they must have actually been together at that time. Fourthly, he looked at the fossils in the north. He also looked and saw that the first thing he saw is that they seemed to fit together like the puzzle, like pieces of a jigsaw puzzle. But fourthly, he looked at the fossils in the north and found that they could only have lived in the south. So the Earth itself must have moved from the south to the north. And for that reason, was he celebrated or heralded as the greatest geologist ever or the greatest scientist? Far from it. He was vilified. He was laughed at. He was made the laughing stock of the geological and scientific community. In their opinion, they thought that that's ridiculous. How could they split apart? They followed their opinions and ignored the evidence. You should, in science, follow the evidence, and wherever it leads you, even if it destroys your theory or fact. He died without being knowing that he would be vindicated. He was helping out uh, someone in Greenland in the snow, helping them out, and he left away. He walked away and was never heard of since. So he died not knowing that his theory, and you can call it a theory because it's got the evidence to support it, a true theory, knowing that he'd be vindicated. It remained till I think 1956 or so for another guy to say, well, how it happens. The Earth's crust is on plates which move around, and underneath there's the magma that circles, and sometimes it comes up where the plates meet, where you get all your volcanic activity, and so on. It's called the continental drift theory. But scientists, including expert scientists, can be wrong. So you have a right to question. Even scientists from leading or experts. They could be ignoring the evidence to prove them that their theories are wrong. Or there could be other evidence that supplants a particular scientific thought or enhances it, and actually that's what science is all about. It's actually making mistakes, it's built on mistakes, and correcting them. And in this case, science can make some colossal mistakes. Now, at 65 million years ago, that's important for you. It's a catastrophe for the dinosaurs because the dinosaurs are cold-blooded. They need a light to operate. So in the nighttime, they really are quite lethargic. They can't really operate. Mammals, which you are, you're warm-blooded. So during that time, you have had to stay underground in the daytime. Otherwise, you'd be eaten up. And you can stay underground in the daytime because you're warm-blooded. You can then come out at night and start to eat. But 65 million years ago, Jupiter, being the largest planet, larger than all or more massive than all the other planets combined, it let down its guard. Normally, because it's so massive, it has so much gravitational attraction, it attracts a lot of the debris, the comets, the meteors, the meteorites, the asteroids that could come out down and hit the Earth. But 65 million years ago, it let a big whopper through, and it was so big it got through the Earth's atmosphere as well. It landed in the Yucatan Peninsula in Mexico, caused quite a stir. Blew up a lot of the Earth's material into space, and burnt a lot of the vegetation off as well, because there was so much of a force and energy that happened when it collided with Earth. That the blocked off all the sun. The Earth was circled with all the ashes and smoke and everything, and blocked off the light from the sun. And the dinosaurs became extinct. Mammals, on the other hand, were able to come out and take over all the niches that had been firmly occupied by the dinosaurs, and which is good for you. $10 million years ago, there was another something else, another event that was important for you. North America and South America came together. Before that, they were separate continents. And when they came together, that's caused a change in the ocean currents, which caused a change in the climate of Africa. So Africa could no longer support the amount of, uh, of trees, or grasslands, or savanna. One of you guys said, getting kind of crowded up here in the trees. I think I'll try my luck on the savanna. And as luck would have it, he got his DNA, cosmic ray came through, hit his DNA, and changed some of his physical characteristics so that he and his offspring, and those who could better adapt to the new environment, were able to live and reproduce and form their offspring. And they, again, their offspring, mated, formed somebody else. And so on, and the rest is history. So how did you get here? It took a lot of different events. Most of them, if they hadn't happened, you wouldn't be here. For instance, your mother and father had to come together. They had to meet, so that's a few events. You could ask them sometimes, well, how did you meet your wife or husband? Then they had to mate and produce you, and you have one half of your DNA from your father, one half from your DNA from your mother. By the way, your cells are all pretty well identical. So you could clone yourself like you do in Jurassic Park, because the DNA has the map or the blueprint about of all your, of you. You start off with maybe your stem cells, and then your DNA tells you them how to change into all the different types of atoms that you have. Your eye atom, your nose atom, and so on. That's why they can do stem cell research now, and people perhaps in wheelchairs that can't walk, they will take some of their stem cells and put them in their nervous system where they have the problem, and then eventually may be able to walk again. It's a very arduous and very complex and perhaps dangerous operation, but nevertheless it has been done. But it is, as I say, still in its infancy and quite not done very, very frequently for the reasons I mentioned. And then, of course, your mother and father have to have the DNA of their parents or your grandparents. So you have a quarter of you as part. You're part of a quarter of them, and so on. And for 100 years, you'd be part of 16 different humans, 16 different people. Go back a million years, it'd be 16,000 that you're a part of. And then so all those events had to happen, otherwise you wouldn't be here. And where are you at? Well, you're on Earth, which is one of, is it 10 planets now? I forget. On the solar system, and the solar system is one of 200 billion solar systems in the Milky Way, in the galaxy. And most of the stars that we've seen so far do have planets. Some of them may have life, who knows? You'd have to look and see. They're searching for them now, and they have to be in the Goldilocks, they think, anyhow, between not too close and not too far away from their sun or their star. And if they have oxygen or um, water vapor, they may be more likely to have life, because we think, at least, that those are the two things prerequisites for life. But then the solar system itself, the Milky Way, is one of 200 billion galaxies. And then you had to survive the 1 second, billion to one chance of becoming a particle. Because if you got any particles, then you would be. And then you got, in the first second, you got all your forces. You got your force of gravity, which keeps you up on Earth, and you've got your electromagnetic force, which stops you from falling through the Earth. You got your strong force, which keeps you from flying apart. And you got your weak force, which keeps you from being bombarded by harmful solar rays, cosmic rays, and other particles and objects falling from outer space. So you have, and then of course, this universe. As far as we know, this is the only universe there is. So all those events and million trillions of things had to happen for you to get here. So that's how you got here. And that's how long it took for you to get here. So I'll stop at this stage.